This is Mrs. Carnes. We're going to talk about slope of horizontal and vertical lines. Now, we've already talked about slope in general. We know what the formula for slope is. We know how to find the slope when we're looking at a graph, and when we've been given some points that lie on our line, we can find the slope. In this video, though, we're going to focus on that horizontal and vertical line, and some really interesting things happen. Now, let's go ahead and review the formulas for slope before we begin. As a review, we know that the slope is always going to be using the variable m, and so the formula for slope, we could see it in two different ways. We know that slope is the rise over the run. This is used really well when we actually have the graph of the line in front of us. And then we also know that we can use the formula y2 minus y1 over x2 minus x1. Basically the difference in the y values over the difference in the x values. And we can use this formula when we know the points that lie on a line. And so we're going to take a look at this, and we're going to use this again talking about horizontal and vertical lines. Let's take a look at the horizontal line first. Now, the slope of a horizontal line, we're going to take a look and say, well, how would we actually do this? Now, we have a graph in front of us, but for this one, I'm actually going to use the points that have been given to us. So we're going to use the formula that says y2 minus y1 over x2 minus x1. And we know that we have these 2 points. They've actually been given to us. We could have chosen any 2 points that lie on this horizontal line, but we've chosen the point -3, 3 and the point 1, 3. And so I label my points x1, y1, and x2, y2. And then I can just plug those into my equation that I have written down. So y2 is 3 minus y1 is 3, divided by x2 is 1 minus x1 is -3. So when we simplify this, 3 minus 3 we know is 0, and we know that 1 minus a negative becomes positive, and so we go 1 plus 3 is 4. Now let's think about this for just a minute. You should remember that when you have a 0 in the numerator, that this number just becomes 0. And so we would be able to say that the slope of this line is 0. And so this is going to work for any horizontal line. Anytime you have a horizontal line, you know that your slope is going to be 0. Now for those of you who actually want to use the rise over the run equation, because it seems a little easier when you're given a graph, let's go ahead and try that. Let's move from this point to this point. So if I start here, I would have to rise and run. Well, if I rise up or down, I'm going to go and move away from that point, and I'll never reach it when I start to run one direction. So that's why the rise is actually 0. We don't go up and we don't go down, but we would run in the positive direction 1, 2, 3, 4. And so that basically is going to give us this value right here, 0, which was the rise, 4, which was the run. But when you simplify that, it still comes out to be 0. So either way you choose to do this, whether you have the horizontal line in front of you or you want to use the points, the horizontal line is always going to have a slope of 0. Let's take a look at the vertical. Vertical lines go up and down, so we can see that we have this vertical line here. It intersects lots of different points. We could have chosen any of those points. We're going to take a look at the point -1, 3 and -1, -1. So we're again going to use the formula that says y2 minus y1 over x2 minus x1. We're going to label our points as x1, y1, and x2, y2, and we're going to plug those points into our equation, and we're going to end up with -1 minus 3 divided by -1 minus -1. And when we simplify this, we're going to end up with -4, and then we have -1, this becomes plus 1. Now -1 plus 1 ends up with 0. Now this should be sending bells and whistles to go off in your head. If you remember, a 0 in the denominator is never allowed. We actually call this undefined. And so we would say that the slope of this line is undefined. The reason it's undefined is because 0 ended up in the denominator, and we're never allowed to have a 0 in the denominator. So the slopes of all vertical lines are going to be considered undefined slopes. Now let's take a look at that rise and run again. If I wanted to try and go from this point to this point, my rise and my run, I would rise, I wouldn't go up to get to that other point, I would go down 1, 2, 3, 4. Since I went down, it would have been a -4, just like we had in our equation. And then we would run. Well, I wouldn't want to run right or left. I'm on my point. So my run, left and right, wouldn't move, so I would be at a 0. But again, when you reduce that or simplify it, you have that 0 in the denominator, which makes the whole value go undefined. So again, no matter which part of the slope formula you use, if it's a vertical line, your slope is going to be undefined. Now, you don't have to use the formulas every time. Anytime you see a horizontal line, you're going to know that the slope is always going to be 0. And anytime you see any vertical line, you can know that the slope is always going to be undefined. You will never have to use the formulas unless you want to prove that the slope of a horizontal line is 0 or the slope of a vertical line is undefined. So you probably want to have these two memorized. Okay, excellent job.